Okay, round two. So this is still 2008, but this is part B. So you're given the structures of dimethyl ether and ethanol. And you're told that the normal boiling point of dimethyl ether is 250 Kelvin, whereas the normal boiling point of ethanol is 351 Kelvin. Account for the difference in the boiling points, and you must discuss both substances in your answer. Okay, so same deal. Make a chart. Put your molecules at the top, put your little structures at the top. And I probably should have, let me do one thing real quick. Put boiling point here. And this boiling point was 250 Kelvin, and this boiling point is, here we go. So we can see from the question like what we're dealing with. So you're supposed to explain why dimethyl ether has a lower boiling point than ethanol. So here we go. Looking at the structure, is dimethyl ether polar? Yes. Okay. There is a molecular asymmetry. Bond dipoles do not cancel. So you're going to have a dipole that exists right around this oxygen, okay? I apologize. Obviously, I'm doing this at school. Okay, so then if you look at your ethanol, yes, it is polar as well. So yes. And we can just copy this. And there's also asymmetry there. Okay, so obviously you should see like, ooh, an OH group. I know not only is that going to be polar, but hydrogen bonding can occur there. Okay, so then we scroll down. I'll talk about IMFs. So in this case, I'm not putting either of these in water. I'm just going to boil dimethyl ether. So I've got a bottle of dimethyl ether, and I'm going to boil ethanol. I've got a bottle of ethanol. So I don't need to talk about water, nor should you, in this response at all. So the IMFs in dimethyl ether, it is polar. So I know I'm going to have dipole interactions, or IMFs, and I'm also going to have London dispersion forces. Everything has London dispersion forces. Type them. Just do it, because if you don't put LDFs, you may get a point taken off. So, or you may not get full credit for a multi-point answer. All right, and then if I go back up to dimethyl ether, it is important that you realize that it cannot hydrogen bond with itself, because none of its hydrogens are directly bonded to FO or N. And in order for hydrogen bonding to occur, yes, there is an oxygen. That oxygen does not have hydrogen bonded to it. So dimethyl ether molecules cannot hydrogen bond to other dimethyl ether molecules. Ethanol, however, can. So if I bring another ethanol molecule close, because this hydrogen is directly bonded to oxygen, not only can this hydrogen be attracted to an oxygen on another ethanol molecule, but this hydrogen on ethanol, on a neighboring ethanol molecule, could be attracted to oxygen. These 5 hydrogens will not hydrogen bond, just the one that's on the oxygen. So here, we're going to have hydrogen bonding. You're still going to have dipole interactions because the molecule is polar. And you're still going to have LDFs. Everything has LDFs. Oh, I did leave a spot for the boiling point. Oh, well, we read it. This is, and then this is, there we go. So why is the boiling point of dimethyl ether lower and the boiling point of ethanol higher? Okay, so we're going to say when boiling occurs, intermolecular forces of attraction must be overcome. Therefore, energy is required to boil to overcome those attractive forces. The IMFs in dimethyl ether are not as strong as they are in ethanol because there is no hydrogen bonding between, molecules of this substance. Okay. Therefore, less energy is required to boil dimethyl ether, hence the lower boiling point. Okay. All right. So I don't need to say that I need to overcome attractive forces again in the ethanol. I've already said this, but I do need to say the IMFs in ethanol are greater, or let's say stronger, than those in dimethyl ether because ethanol molecules can form hydrogen bonds. This is a stronger IMF than dipole. Dipole attractions, thus more energy is needed to overcome hydrogen bonding. Therefore, ethanol has a higher boiling point, and that's it. Okay, so again, you're not going to talk to yourself like I'm doing right now. You're not going to take as long to answer this question, but everything is organized. I'm going to back out so you can see. So I have the Lewis structure. So I'm saying, hey, I'm looking at the structure. I know the structure is going to tell me something about IMFs. I'm looking at the boiling point. I'm deciding, are these molecules polar or non-polar? Well, they're both polar, okay? But the difference comes in terms of the types of IMFs. So they both have dipole attractive forces. They both have LDFs, but ethanol can hydrogen bond to other ethanol molecules, and dimethyl ether cannot. And there's the difference. So I need to explain that in my justification. So there you go. I'm going to post this one as well.